briefly demonstrate how to use a digital experiment that models a cross flow or an extended area heat exchanger. This is in some ways similar to a car radiator in that water is flowing through thin tubes which have attached fins. And in this case, we're going to measure temperature of the air before and after flowing across the fins, across the exchanger. We'll also measure temperature of the water in the tank. So this water, once we start, will circulate through and back into the tank. You can adjust the flow rate with the valve here. And then the thermometer output is shown on this meter here. So we'll look at the simulation. So here we can start the fan by clicking here. We can start the pump, and then we can adjust the flow rate of the pump. And so what I'm going to do, if I use the scroll wheel, I can expand this, make it easier to see, and then you can see the flow rate that's given here. So I'll zoom back. Let it run for a few seconds here. We have thermometer 2, which is here. The temperature of the tank started at 6 degrees. It's dropped. We can also read the temperature that's coming out of the water that's gone through the exchanger, and that's lower than the temperature in the tank. We can measure the temperature of the air coming in, this high temperature. So if we click on this thermometer, it moves to the other side. We can see the temperature is significantly lower on the other side, and it's continuing to drop, as is the temperature of the water that's flowing out. And so we can do energy balances to calculate the heat transfer. And that's the main objective here. The simulation has some directions that talk about what I've just mentioned. And then it also has the detailed worksheet that leads you through the calculations, indicates what measurements to make as a function of time, and particularly comparing as the temperature changed significantly in the tank.